Hello everyone, I am Girish P. from Sri Venkateshwara College of Engineering. Today we will be discussing about the joint probability distribution. Introduction of joint probability distribution. Joint probability distribution is a statistical concept that describes the simultaneous probabilities of multiple events occurring together. It provides a way to analyze the relationship between two to three random variables. The joint's probability distribution can be represented using a joint probability mass functions or a joint probability density function. Joint probability distribution. The joint probability distribution of two random variables is equals to biverted probability distribution. The joint probability distribution of two discrete random variables is usually written as P of x is equals to x, y is equals to y. Next, definition of joint probability mass function. The joint probability mass function is a function that assigns probabilities to every possible combination of outcomes for multiple discrete random variables. It is denoted as P of x is equals to x, y is equals to y, where x and y are random variables and x and y are specific outcomes. The joint probability mass distribution mass function satisfies certain properties such as non-negatively normalization and the sum of probabilities equaling 1. Next, example of joint probability mass function. Considering two dice rolls, the joint probability mass function would provide probabilities for each possible combining of outcomes such as P of x is equals to 1, y is equals to 2, or P of x is equals to 3, y is equals to 4. The joint probability mass function can be represented in a tabular form where each cell corresponds to a specific combination of outcomes and its associated probabilities. Next, definition of joint probability density function. The joint probability density function is a function that describes the probability density for multiple continuous random variables. It is denoted as f of x is equals to x, y is equals to y, where x and y are continuous random variables and x and y are specific values. The joint probability density function satisfies certain properties such as non-negatively and integrated over our entire supporting equalize 1. Next, marginal distribution. Marginal distribution are obtained by summing or integrating the joint distribution over one or two variables to obtaining probabilities and or probability density for individual variables. Marginal probability mass functions or probability density functions provide information about the probability of a single variable, ignoring the other variables. They can be derived from the joint distribution by integrating over the upward variables. Conditional distribution. Conditional distribution describes the probability distribution of one variable given the variable of another variable. The conditional probability mass function or probability density function can be obtained by normalization the point distribution with respect to the given condition. Conditional distribution can provide insight into the relationship between variables and can be used to prediction or inference. Independence of random variables. Two random variables x and y are considered independent. It can be joint distribution can be factorization into provides in the marginal distributions. The independence imposes that the occurrence of one event does not affect the probability of the other event. The joint distribution of independent random variables simplifies that the production of the individual distributions. Covariance and correlation. Covariance measures the linear relationship between two random variables in the joint distribution. It quantities how changes in one variable are related to changes in the other variable. Correlation is a standardized measure to covariance that ranges between 1 and 1 indicating the strength and direction of the relationship. Joint probability distribution in practice. Joint probability distribution is widely used in various fields such as finance, engineering, and healthcare. It allows for modeling complex systems and understanding the interacting between multiple variables. Applications included risk analysis, portfolio optimization, relatability analysis, and disease prediction. For example, X is the time until a computer server connected to the machine. Y is the time until the server authorized user to the valid user. Each of these random variables measures the weight of the common start time of X is less than Y. Assuming that the joint probability density function for X and Y. Limitations and challenges. Constructing joint probability distribution may require a large amount of data. Estimating the joint distribution accurately can be challenging, especially for high-dimensional data. Interpretation of the joint distribution requires careful consideration of the underlying assumption and limits. Next, conclusion. Joint probability distribution provide a powerful tool for analyzing and simultaneously probabilities of multiple events. It allows for understanding the relationship between variables and the making predictions or inferences. By considering joint distribution, we can gain valuable insight into complex system and make information decision. The joint probability distribution is two random variables that is equals to bivariate probability distribution. The joint probability distribution of two discrete random variables is usually written as P of x is equals to x, y is equals to y. Thank you for watching.